Okay. Hello everyone. Today's topic is about fusion and fission. Okay, so let's move to the first part about fusion. Okay. So maybe when you first heard this word, it's a little bit difficult for you. But for fission, I guess here in this figure, you can see it very clearly and easily. Okay. So first you can find there is a very tiny ball, or you can say it's a very tiny particle. Okay. And it hits on a very big particle. Okay, you can find here. Maybe here is just for a neutron, okay? But for here, maybe like it's uranium 235, okay? A very, very big relative mass atom, okay? So when the neutron just hit on the very big atom, you'll find, oh, it releases two neutrons, okay? And also because after the collision, you can find it just cut off in a half, okay? So uranium also becomes like other atoms and it divided into two parts, okay? So here we can find the two extra neutrons just hit on other two new particles, okay? So it will release more neutrons and more particles. So you'll find that, oh, after one collision, it will like collide the second time, the third time, the fourth times with more particles automatically, right? So here we can say it's a kind of like principle of free fission. Okay. So you can find the fission is just like one hit one and release two, two release three or five, or like releases seven or eight. Okay, it can release more. So you can call this reaction a chain reaction. Okay. You find it just like a chain, right? Okay. So here's like a very interesting chain and the particles becomes more and more. Okay, so this is fission. So because of the chain's rule and because it can release more particles and can release more neutrons and can react automatically. Okay, so this can build the nuclear weapon. Okay, so you can find this figure. Yes, this is like a mushroom cloud, right? A very dangerous nuclear fission principle. Okay. So based on this, we can find that all the reaction or all the chains in the graph can release energy. So like after one by one, it's just like an indices calculation. Like first is one, and then two, and here is two cube, and here is two square, two cube, and maybe two fourths and more. Okay, so the like energy of this will just like increases by indices. Okay. So it will become bigger and bigger, and it can release a lot of energy. Okay, so this is for fission. Okay, and in our daily life, fission can using in a nuclear reactor. Okay, if the city is lack of the energy, like lack of the carbon, lack of the gases, so you can use the nuclear reactor to give more energy for the city. Okay. So you can find here, there is a nuclear reactor in the figure, okay? And here you can find there are the nuclear fuel in the core, okay? There are several cores and there are control rods and can like just divided them into different parts. And there is a steel pressure vessel right here, okay? And when you put cool water into the container and it will release the hot water outside, okay? So we can say this is a fission in the nuclear reactor, okay? So here you can find there's more about the fusion. Okay, so fusion is just quite different from fission, right? And we can see before, like fission is just from very big particles just divided into some small particles and small pieces. But for fusion, you can right here, see right here, and fusion just is there's a reaction, an example for fusion, and there are hydrogen 2 and hydrogen 3, and they combine together to form the helium 4. Okay. So you can find there are very tiny particles and they can form together and release a neutron, okay? I guess it's not very difficult for you, okay? So maybe many times you heard about nuclear fusion and controllable nuclear fusion, right? You can find many scientists, like these days, they are just like making investigation about how to control the nuclear fusion, okay? So you can find this reaction also releases energy and that can be used by human beings, okay? Can also release energy. And the main difference between the fission and fusion is that fission is a reaction from a very large or very big particles. So sometimes you will find in the fission like reaction formula, they are very, very like 235 relative mass for the atom, or maybe more, like 237, or maybe 137. Like you'll find that there are hundreds of the relative mass that it must be a fission. Okay. But for fusion, there are very small particles. Like here, you can find there are like relative mass maybe equal to 2, equal to 3, and they form 4. They are very small reaction, okay? But they can release more energy than fission, okay? Fusion can release more energy than fission. These are the principle, okay? So why fusion can release more energy than fission? There is a very like example we all knew. Here in the sun, we can find there are core. And why core like it's very high temperature? Because inside of the sun, there are many hydrogen react with each other for every time. Okay, so their like amount is very big, and after the nuclear fusion, they form the helium, and they can release a large amount of energy. Okay, so the sun can still burning, like burning about 50 million degrees Celsius, and can releases many energy. But there's still a age for the star because for down there's not enough or there's not unlimited hydrogen inside of this. Okay, so after the hydrogen burn, maybe here you can find burnout if they're just used up or they can just cannot release energy anymore. Okay, so here are some exercises. So I will take you to do the first exercise. Okay, so here in the question is that a scientist was asked to separate the following equations into two categories. Like first is nuclear fission and second is about nuclear fusion. Okay, so which equations show nuclear fission? Okay, I think this is very interesting question, right? So for nuclear fission, we said before, like these are the very big particles, like divided into some small particles, right? So you can find in the Formula One, there are just like Pu 239 divided into the Pd 120 right? So here the reaction must be a nuclear fission, right? You're gonna find a very big particle, like hundreds of relative mass divided into hundreds of Pd and Cd right here. Okay, so this is a kind of nuclear fission. And in the second formula, you can find your helium, react with helium, and form the helium and two hydrogen, right? So this cannot be a nuclear fission, right? Because we can say nuclear fission is very big particle, and here is very small particle. We can say it might be a nuclear fusion, right? Okay, so maybe for the third formula is all like the same like situation, like you can nitrogen, hydrogen, and oxygen, they are very small particles, so they can or they might be nuclear fusion. Okay, you can find the nitrogen is 14 and is fused into a like bigger relative mass 15 carbon. Okay. And for the fourth formula, you can find your uranium 235, then 2, and you can form the crypto and for the Bayesian, right? So it must be a nuclear fission. It just divided the very big particles into two smaller particles. Okay. So we can say, oh, maybe finally we choose 1 and 4 as our nuclear fission. Okay. So finally we are choosing C. Okay. Okay, so here's another exercise for you. Okay, so can you try to solve the problem on yourself, please? Okay, so take your time, please. Okay, so for this reaction, we said like there are two principles to write them down, right? So for the first principle, you have to make them the charge balance, right? So on the left equation, it must equals to the right equation, the char, right? So you can find here, like 6 can is doesn't equals to 7 plus 1, so A we cannot choose. And for 14 equals to 14 plus 0. Yes, that's correct. But beta particle is like take one negative charge, right? So B is also not correct because here it must be -1. And here you can find 6 equals to 7 plus -1. It's correct, right? And D is also not correct, right? So finally, we can choose C, right? And second, like principle is about the relative mass equals to each other, right? Relative mass balance. So for relative mass balance with the other, you can find here that there is 14 equals to 14 plus 0, right? So here we can say, oh, here is also a balance equation, and you can find the relative mass equals to each other. Okay, so finally, we are choosing C as our final answer, okay? So I guess it's also not difficult for you, right? Okay, so finally, we're choosing C. Please remember that charge balance and relative mass balance in the equation, okay? Okay, so this is for our today's lesson. I guess it's not very difficult for you. And after the class, I hope you can do some homework and trying to do some past papers, topic papers to try to like make your knowledges to enhance. Okay, so see you next time. Bye.